so we're going to look at day number 8 of our 24-day extravaganza, and this one is on material science. So I've got 4 graphs, a stress strain graph here of 4 different materials. This question's a bit of written, so there's a lot of written in here, as well as a little bit of calculation, so this will be quite good here. So the first question is state. So state is a very factual thing. Normally when it says state or define, you are, with certain things, you are looking at equations. So it says state what is meant by tensile stress and tensile strain. So tensile stress is the force per unit cross-sectional area, which is basically F equal, tensile stress is force divided by the area there. And the tensile strain is the change in length, per unit original length. Okay, so what we have here is change in length over the length there. And they are just literally worth 1 mark each. So when it says state and you're given quite a few centimetres, you can write the equations, but you must explain what each of the points mean. So if you're going to write F over A, you must say that F is the force and A is the cross-sectional area, and delta L is the change in length and L is the original length. That's what they're looking for here. So identify the property of material A. So identify the property. So what property is material A showing? Using evidence to support your choice. So A, that material is its property, so identifying it, it is brittle. Okay, and the evidence for this, the reason I know this is a brittle material, because it breaks before there is a plastic region. Okay, so it breaks before reaching a plastic region there. Okay, so 1 for mentioning brittle and 1 for saying it breaks before reaching a plastic region. So this is their wording. We've actually got a 6-mark question right at the bottom of this. This is the maths part of it. So a cylindrical specimen of material A under test conditions has a diameter of 1.5 times 10 to the 4 and a breaking stress of 1.3 gigapascals. What is the tensile force acting on this specimen at this point? So I'm going to be using stress equals force over the area. So stress times by the area equals the force. So it's a diameter, it's got a wire. So the area, of course, is going to be pi r squared. So it's going to be pi times the diameter divided by 2. So that's going to be 0.75 times 10 to the minus 4 squared. And that's going to equal 0.75 times 10 to the minus 4 squared. And then times that by pi is, so the area is 1.767 times 10 to the minus 8 meters squared. Okay, so my force equals 1.3 times 10 to the 9, because it's giga, times by 1.767 times 10 to the minus 8. So 1.3 times 10 to the 9, and I get an answer of 22.9 newtons there. Probably closer to 23. I get 22.97, which is approximately 23 newtons there. Okay, so mark-wise, you got 1 mark for working out the area correctly, 1 mark for using the formula, and 1 mark for getting 23 newtons. Okay, so this one, discuss. Discuss questions mean that you have to talk about pros and cons, good things and bad things. You are discussing, okay? Which of the 4 materials shown on the graph are the most suitable for each of these applications? The cable supporting the lift and a rope or cable doing a bungee jump. For each application, you should discuss the reason of your choice and why you have rejected other materials. So 6 marks, so I'm going to say 6 things. There are 2 topics that I need to talk about, which is the cable supporting a lift, the rope doing the bungee jump. So the first thing I'm going to do is I've got the lift. Okay, so this is the lift situation. Now, you can in 6 marks questions write bullet points, but they have to flow. Okay, so the lift. So I'm going to choose a material for my lift here. So looking at here, I want, for a lift, you don't want something that's just going to snap brittly. I'm going to want something that which will stretch uniformly, and then we'll have a plastic region. So I want B or C. I'm going to choose C, okay? So I'm going to first of all state the material that I want. So I want material B/C, okay? And then, okay, so you discuss the reason for your choice. So that's another point. So I'm going to explain why. And then I'm going to choose a reason that I didn't choose another material. So for the lift, I want material B or C because B and C have plastic region. And it means it would deform before it fails, meaning it is safer. So what it means, if it has the highest amount of stress on this, it's going to deform before it's over, which means it is safer, because what you're not doing is you're not having this harsh breaking point. Which leads me to why you rejected the other materials. Material A is brittle, which means when you reached maximum stress, it breaks rather than deform, which is less safe. So I mentioned the fact that because when the B and C are going to deform before they break, A does not do that, so it's just going to snap when it reaches its maximum stress. It's not as safe. Okay, so there we go. I've mentioned material B and C. I've mentioned a reason why I would choose it, and I've mentioned a reason why I wouldn't choose A. So I've mentioned this, I've put the reason for my choice, and why I've rejected the others. The next thing you need to do for the rope attached to a bungee jump. So this is another section. So bungee jump. So I've done 3 bullet points. Bungee, jump. Okay. So for that, I'm going to choose a bungee jump is a material which is very elastic. Okay. So basically stretches under very low loads. And that material, of course, is going to be object D. Okay. So I'm going to choose the material. So the material is material D. And the reason I have chosen this is because it has the most extension for the least stress. So we'll extend through the whole motion of the bungee jump here. So I'm mentioning the fact that it's going to stretch a lot, okay? It's going to have a lot of stretch, okay? So it's going to have a lot of stretch before it breaks, okay? Now, what material won't I choose? Again, I wouldn't choose material A. Material A is brittle and has little stress or strain, or change in length, which is not desirable during a bungee jump. Okay. So what I've done here again, I've mentioned the material I want, I've said why it's good, and I've said why it's bad. So actually go to the mark scheme here and actually look at the top level. So the correct materials selected for each application, so B, C for the lift and D for the bungee. One reason for the choice is given for each application, and an explanation why at least one other material will be rejected for each application. That is a level 3 6 mark thing here. So how I did that is, of course, I looked at the topics here, and normally they will give you things they want you to talk about. And normally that implies topics or headings that you could look at, okay? And then it's actually telling you what to do. For each application, you should adjust the reason for your choice and why you rejected other materials. So I have taken that as going, cool, I need to say 6 things because it is a 6-mark question. I need to tell me, I've got my topics, I've got the lift and I've got the bungee jump. I need to tell you what material I am choosing. I've got to give you a reason why. And then I've got to give you a reason why I didn't choose something else. So what I've done there is by putting those 3 bullet points under each of those topics, I have got my 6 marks. Okay, so this is really important with 6-mark questions. As you can see here, I have not, I've used bullet points, okay, but my bullet points are clear and what they identify. And I've always followed the same pattern. I've told you the material, I've told you why it's the material, I've told you why a bad material's there. Okay, so there we have it. This is actually more a wordy question. So like I said, discuss is all about pros and cons, and that's exactly what we did. We said a good thing about the material, and then we said a bad thing about another material there. So that's normally what you say in discuss there. So there we have it. That there is question 8 of this Advent extravaganza.